Let's go ahead now and fill out our flip book so you have a reference on the steps that you should follow in order to simplify radicals. And the reason we're doing this is because there's going to be situations where you're going to end up with a final answer in this course, and it's going to end up being a radical or a square root. Sometimes I'm going to ask you to just plug that number in your calculator and get a decimal estimate. Other times I'm going to ask you to leave it as a radical but simplify it. So you're going to need to know how to go through the steps of simplifying a radical. So this section is found in your flip book in section number 4. It's the top flap in section number 4. So go ahead and turn to that right now. And you can see that I've already filled in the title up on the top here, Simplifying Radicals. And again, remember, we can use the word simplifying square roots. We can use the word square roots or simplifying roots. There's lots of different names to call this. I like to use the word radical, but you could just as correctly say simplifying a square root or simplifying a root. So here is our title. Let's go through the steps of simplifying a radical or a square root. The first step, step number 1, is to prime factor the number inside the radical. Prime factor the number inside the radical. Now, if you need to pause the video to write this down, if I move too quickly, you can go ahead and pause it to make sure you get that written down exactly. There's the first step, as we did in our notes. Prime factor the number inside the radical. Step number 2. Write the prime factors in order from low to high. So if you got prime factors of 2, 3, 5, and 7, you'd put them in that order. If you ended up prime factoring and getting 7, 5, 2, and 3, you'd write them from low to high. If you have duplicates, you put them next to each other. So you might have, say, something like 2, 2, 5, 7. So write the prime factors in order from low to high. Next step, for every pair of like numbers, one escapes the radical and the other is canceled or crossed off. And that's because they form a perfect square. For instance, if you have 2 3s as part of your prime factoring, 3 times 3 is 9, and we know the square root of 9 is 3. So 3 gets out of the radical, the other 3 is crossed off. So as we saw in our examples in our notes, you look for pairs, match them up in groups of 2 like numbers. And if you can find 2 numbers that are the same, one of them escapes the radical, one of them is canceled. If you have a number that's all by itself, then there's nothing you can do about that. That remains inside the radical. And then the last step is, let's go ahead and scroll up and show you this. The last step is combine by multiplying the remaining numbers in the radical and do the same with the numbers outside the radical. So if you have more than one number that escapes the radical when you're doing step number 3, you'll remultiply those numbers together. And if you are left with more than one number inside the radical when you're done with step number 3, you can recombine those together by remultiplying them. Let's go ahead and do a couple examples in our flip book. So we'll take a look at the square root of 27. Step number 1 says prime factor the number inside the radical. So I'm going to do that right now. I'm going to write the number 27 over here. Let's go ahead and prime factor that. I know that 27 is 3 times 9. 3 is a prime number, so we're done with that one. 9 can be prime factored into 3 times 3. And those are prime numbers. We can circle those and we're done. Step number 2, write the prime factors in order from low to high. So now I'm going to rewrite my radical. It looks like we have all 3 numbers the same. So I'm going to write them as 3 times 3 times 3. And I hope you can agree that the square root of 27 is exactly the same as the square root of 3 times 3 times 3. If you multiply these together in your calculator, 3 times 3 is 9, times 3 is 27. So we see that these two expressions are equal or equivalent. Step number 3, for every pair of like numbers, one escapes the radical and the other is canceled. Let's take a look. We have a pair of numbers that are the same. In this case, the first two 3's. Oops, I'm going to change that to a different color here if I can. So let's mark that as a pair of numbers that are the same. And we learn from step number 3 that one of these 3's escapes the radical. One of these 3's is canceled. So this one got out. I'm going to just cross that off to show that that one got out. Actually, let's put a circle around it to show that it got out. This 3 was canceled, and we're left with a 3 inside the radical. So now we can see that our simplification is done. 1 3 escaped, 1 3 was crossed off, and this 3 does not have a pair or a partner, and so it cannot be removed from the radical. So our simplified radical for the square root of 27, fully simplified, is 3 times the square root of 3. Let me try that a little bit better. I'll do that in a different color so you can see that a little bit better. There is our final answer. Okay, let's go ahead and do square root of 48. Another example. Notice for number 1, by the way, we didn't need to do step number 4. There was only one number on the outside of the radical, so it doesn't need to be recombined. There's only one number that remained in the radical, so there's nothing to combine there. Okay, step number 2, or question number 2. Let's go ahead and prime factor this. So I'm going to write the number 48. And I know that this is an even number. That means 2 must go into it. And if you look at your calculator, 48 divided by 2 is 24. 2 is a prime number, so we are done with that one. 24 is also an even number. That means 2 goes into 24. 24 divided by 2 is 12. This is a prime number, so that branch is done. 12 can be divided up, also an even number, so 2 goes into 12, and that has a remainder of 6. Sorry, not a remainder. 12 divided by 2 is 6. 2 is prime, that one's done, and 6 is 2 times 3. Those are both prime, so we're done with those. So 48 is the same as 2 times 2 times 2 times 2 times 3. Let's go ahead and write that out. The square root of 48 is equivalent to the square root of 2 times 2 times 2 times 2 times 3. And if you put those in your calculator, 2 times 2 times 2 times 2 times 3, you'd get 48. All right, let's take a look at our pairs. Step number 3. And notice also I wrote these from low to high. That's step number 2. Step number 3, let's mark our pairs. We got 2 2's, there's a pair. We've got another pair of 2's. It looks like 3 is going to be all by itself. That one is going to stay inside the radical. Remember, for each pair, one of them escapes the radical, so I'm going to write that down as 2. One of them is removed or canceled. This 2 escapes from this pair. This 2 is canceled. And then we have number 3. The number 3 does not escape the radical. That stays inside. Notice I put a multiplication here because everything we're doing in this case is multiplication. There's no adding or subtracting here. And step number 4, now the final step, is to write our final answer. The 2 2's escape the radical. We can recombine those or remultiply those. 2 times 2 is 4. And we're left with the square root of 3. The radical 3 is left over. And here is our final answer. Square root of 48, completely simplified, is 4 times the square root of 3. Let's go up to now question number 3, or example number 3, the square root of 70. Square root of 70. First thing we do is, let's go ahead and prime factor. So I'm going to write 70 over here. I know that 2 goes into 70 because it's an even number. 70 divided by 2 is 35. This is a prime number, so we're done there. 35 is not even, so 2 doesn't go into it. 3 doesn't go into it. 4 does not go into it. 5 does go into 35. And 35 divided by 5 is 7. Those two numbers are prime numbers. So we're done with our factor tree. Step number 2, let's write our radical over again with our prime numbers, or prime factors, in order from low to high. 2 times 5 times 7. Now take a look at question number 3. There are no pairs inside the radical. That means none of these numbers can escape. So when you look at the square root of 70, you'll find out that the square root of 70 is already simplified. It cannot be simplified any further. So in this case, you basically just go back and say, you know what? I can't remove any numbers from the radical, so my final answer is going to remain the square root of 70. Okay, last example, question number 4. We've got 2 radicals, and we need to simplify this fully. Now, there's a couple different ways to do this. I would recommend you don't try to combine these together. You've learned that this is just the square root of 27 times 12, but then you end up with a huge number, and you have to figure out how to prime factor that. It's a lot easier just to prime factor these smaller numbers. So let's do that right now. 27 is not even, so 2 does not go into 27, but 3 does. 27 divided by 3 is 9. We can prime factor 9, which is 3 times 3. So the prime factoring of 27 is 3 times 3 times 3. Let's go ahead and prime factor 12. 2 goes into 12. 12 divided by 2 is 6. 2 is a prime number, so we circle it. 6 is even, so 2 goes into 6. 6 divided by 2 is 3. Both of those numbers are prime numbers. So now we're done with our prime factoring. Well now, since these two radicals are multiplied together, we can put all these numbers in the same radical. So let's go ahead and do that. This is equivalent to, start with our lowest numbers. We've got 2 2's. And we've got 1, 2, 3, 4 3's. 1, 2, 3, 4. So this is all one radical because this is a multiplication problem. And now we can go ahead and pair up and make this a whole lot simpler. The 2's pair up, these pair of 3's pair up, and these pair of 3's pair up. You see right now, we're not going to be left with anything inside the radical. We're going to be left with a whole number. 1, 2 escapes, 1, 2 is canceled. 1, 3 escapes, 1, 3 is canceled. And 1, 3 here escapes, and 1, 3 is canceled. Nothing is left inside the radical, so all we have to do is multiply these numbers together. 2 times 3 is 6. We still have times 3 left. 6 times 3 is 18. So our final answer here is 18. And if you were to take 27 times 12 and put it in your calculator, you would get a number. If you square rooted that number, you'd actually end up with exactly 18. So our final answer here is just a whole number 18 with no radical. And that is the end of the top flap of section number 4, simplifying radicals.